So today's lesson is on angle relationships in quadrilaterals. So remember, you may remember from from elementary school, from grade school, that quad means four. So quadrilaterals are simply figures or shapes, polygons with four sides. Right, so we have a variety of different ones here, which you may remember, and we did review earlier this year. At this point, it's really not critical that we remember the names of each of these quadrilaterals, but just that we understand some general ideas. So I'm gonna show you what I mean by that. So if you remember that the sum of all of the angles in a triangle is always 180, I want you to think about a quadrilateral, and I'm going to use this first purple one as an example here. I want you to think of every quadrilateral as being really just made up of two triangles. And I know that all of the angles in this triangle have to add up to 180. And, and that the same is really true for all of the angles in the second triangle that I'm seeing. Right? So, really, all of the angles in the one triangle are 180 degrees. All of the angles in the second triangle are 180 degrees. And 180 and 180 together give me 360 degrees. And you would find that, quadrilaterals can be split into two triangles in different ways, and that holds true for all. That principle holds true for all quadrilaterals. Now I want to get into the specifics. So you may remember that a trapezoid has two lines that are parallel to each other. And so if that's the case, then we can use some of our properties of parallel lines to help us solve problems in this case. So the one that I see most often with trapezoids used is, our co-interior angles, the C pattern. So that means that, this angle here and this angle here, I'm going to call the first one X and the second one just above it Y. I know that X plus Y has to equal 180 degrees. That's C pattern. Right? So remember, I could also draw a C pattern, a backwards C, and that would be equally, that same property would be there as well. Secondly, a parallelogram. A parallelogram has two sets of parallel lines. So here's another set of parallel lines, there's another set of parallel lines, and there's the second one. So parallelograms, what we just saw with trapezoids with our C pattern still exists. So for example, right here, that certainly exists. But what I find that is particularly useful for parallelograms is, to remember that because we also have parallel lines in the other direction. So what I mean by this is really I could look at it like, this is sort of like a sideways C. Right? And so I also could draw almost like a letter N right here, because these two lines right here and right here are also parallel. Right? So those are important things to consider. I'll show you how that's useful. Okay? So what that allows us to say is that if I know the measure of this angle right here, well, let's give it a value, and maybe this will make it a little bit more real for you. Let's say I'm just going to pick an easy number, 60 degrees. Then I know that the value in here, along with the 60 degrees, has to add up to 180 degrees. So that's my C pattern. So that tells me that this angle right here is 120 degrees. Well, remember that we said that there's a C pattern here as well, right? And so that tells me automatically that this little angle here is also 60 degrees. And looking at my backwards C, I know that this angle, my 60 degrees up here and this angle below have to add up to 180 degrees. So that gives me, that tells me that that final bottom right angle is 120 degrees. So I'm going to do this instead. All right. So, well, what do you see? Well, you should see that the opposite angles in this parallelogram are equal to each other. That's super helpful. But notice that the same trend does not exist with the trapezoids. I can see here that angle Y, just visually too, angle Y in angle, this angle here in the bottom right, are not equal. I can tell that just visually. This angle here at the bottom is acute, whereas this angle up here, y, is an obtuse angle. And so those are helpful hints, although not all diagrams are drawn to scale. So I think now we've gone over the basics and we're ready to start looking at some examples. All right, so this is a quadrilateral that, you know, it doesn't really matter if it's familiar to you or not. What you're asked to find in this case is what the value of the measure of angle n. And so when I look at this, I know that all of those angles have to add up to 360 degrees. Right? So angle n plus the 78-degree angle plus the 127-degree angle plus the 43-degree angle, all of those are going to add up to 360 degrees. So really what I need to do is I need to say, well, if all of the angles add up to 360, I'm going to take away the 78 degrees, the 127 degrees, and the 43 degrees. And the difference between those should give me the remainder, which is my unknown angle. Then I'm getting 112 degrees. And that seems reasonable. So not too difficult, just applying simple principle of quadrilateral sum. Here's another example. Now what's missing here that really should have been included, I'm going to include it for you now, is the fact that I have two sets of parallel lines. And that immediately tells me that I have a trapezoid. And so the fact that I have a trapezoid makes this a little bit easier. It seems like they don't give me a whole lot of information, but actually knowing it's a trapezoid helps a lot. So what strikes me is that I have these opposing angles in this trapezoid. I keep saying trapezoid. It's a parallelogram. My bad. So in this parallelogram, the opposite angles have to be equal. So that equal to each other. So that automatically tells me that this little y here, the measure of angle y, is also 145 degrees. So what else can I do? Well, I can try to see some C patterns here. I know that these co-interior angles, 145 degrees, and angle Z have to add up to 180 degrees. And so Z is going to be 180 degrees minus the 145 degrees. Right? So 180 minus 145. So 180 minus 140 is going to leave me with 40. Minus 5 more will leave me with 35 degrees. And so there are a couple of different ways that I can use that to help me find out angle X right here. The simplest, I think, is just to notice that in this parallelogram, these angles right here are opposite one another, and that automatically lets me know that angle X has to also be 35 degrees, just like angle Z. Okay, so this example here involves algebra. Again, let's just make sure that you know that these lines are parallel. That makes this a parallelogram. Now I've got some algebra here, and so I'm going to use what I know about quadrilaterals to help guide me through this problem. So what do I know? Well, I know that all of the angles in a quadrilateral have to add up to 360 degrees. That I know. But I don't actually know the value of the angles themselves. I just have an expression that helps me understand the relative size. So really what this is trying to tell me is that angle X versus angle 3X, right? Whatever X is, the angle, you know, up top left is 3 times as large, right? So I'm going to write an algebraic expression. So I know that all of the angles, this angle right up here, this angle here, this one here, and this one here, all have to add up to 360 degrees. So I'm going to write that out. So X plus 3X plus X plus 3X all have to add up to 360 degrees. I've got a bunch of X's here. How many do I have in total? Well, 1 plus 3, 4, 5, and then 6, 7, 8, right? 1, 2, 3, 4, 5, 6, 7, 8. That gives me 8X has to be equal to 360 degrees. I haven't figured out what x is. I could use guess and check for this, or I could use algebra principles of algebra, which is to say that if 8 times x is equal to 360, then I can undo the 8 times x and get x isolated by dividing it out. Whatever I do to one side, I do to the other. And by dividing 360 by 8 gives me a value of 45 degrees. Right? You can always go back and check your answer though, right? So if I were to go ahead and back into this problem and plug in 45 degrees for the value of x, does that actually make sense? Well, let's see, right? So 45 and then 3 times 45. 45 degrees and then 3 times 45. And if I add all of those values up, really, what do I have? Well, I have 3 and 3, so 6 values of 6 45s, 7, 8 45s. 8 times 45 does give me 360 degrees. That lets me know that I've approached this problem in a way that makes sense. Remember that on the calendar, you'll be able to find sections of your workbook that will help with this. But please remember that, section 3.4 homework is where you want to be looking for this, for some extra practice using quadrilaterals and geometry.